from here, there's many different ways you can go, and it's hard to say what's going to be best. You could write the left-hand expression as 3 cos 3x over cos 2x, get rid of one of the squares. You would still have the mess on this side. Although you could put sin 2x over cos 2x to be tan 2x, so you'd have 2 tan 2x sin 3x over cos 2x. I'm not convinced that that would actually be any better. You could try to substitute. So if this was a 2, you would have 2 lots of cos 2x cos 3x plus sin 2x sin 3x. And then you get your formula sheet, and you could go cos plus sin was cos of a difference. And it might actually be useful because you might be able to get 3x minus 2x and get x out of it. But you would still have one more cos 2x cos 3x. Okay, you say, you can write that with another rule from the formula sheet. Cos is this mess. Well, again, I'm not convinced it's going to be any neater, but you could. If it just says find the derivative, this is a perfectly good answer. Okay, I realise there are some of you, given this is specialist maths, who want to see what happens if we do all those substitutions. I am not convinced that this is going to be neater, and I haven't prepared it, so I do not know what's going to happen, and I can assure you it did not get done in the Maths Methods book that I took this example from. However, for the sake of my curiosity as well as yours, let's find out what happens. On the top, I have cos, what am I trying to get rid of? Let me think about this. I'm going to take this, 2 cos 2x cos, I'm going to write this the other way, 3x cos 2x, because it was involved. Where was my rule? Sorry, let me try again. Cos plus sin is the cos of a difference. I'd rather have a positive difference in the middle. So I'm going to write it with the cos 3 before the cos 2. So 2 cos 3x cos 2x plus 2 sin 3x sin 2x plus 1 left, cos 3x cos 2x all over cos squared 2x. I'm really not convinced this is going to be any better, but let's go have a go. This is 2 lots of, now cos plus sin. Cos plus sin is cos of the difference. So that's cos 3x minus 2x, which is x. But I've still got cos, I was going to do that one too, wasn't I? I've still got cos 3x cos 2x. Is this going to be any better? Cos 3x cos 2x is half cos of the difference cos of the sum. Half cos of the difference, which is x, cos of the sum is 5x. Oops, I'm doing something wrong here. Cos of the sum, 5x. What have I done wrong? Did you spot it? There was supposed to be a plus here. All over cos squared 2x. arguable whether this is any better than that, because there's no 2x's in any of these up here for me to simplify anything else with. You might like it better. There's a 2 here and a half here. If I times everything by 2, it'll at least get rid of the half. 4 cos x plus cos x plus cos 5x all over 2 cos squared 2x. And I can make one more simplification. 5 cos x plus cos 5x all over 2 cos squared 2x. So I started with this, and I ended with this. Honestly, this probably is slightly neater, but it probably wasn't worth all that effort. Nevertheless, you could do it if you wanted to. If it was an exam, you better make sure that the exam has enough marks allocated to that question to make it worth the bother.